I would like to start by saying thank you not only for the conference, but also for the library itself. It's been a great pleasure to be using JSXGraph for a long time. I've been using it for my notes for the students or for some demos, and it's also wonderful to be here to see how others are using it and giving us ideas to keep going on the path of using JSXGraph. So thank you very much, not only for organizing this, but for giving us the opportunity to use this wonderful tool. And well, this is something the thing I want to talk about, and also my colleagues from Torino and from Kaiserslautern will join me today as Lukas and Matthias. They will come later today in the talk. It's about a project that is related to sonification of functions, which is called SonarGraph and is funded by the European Union. It's one of these Action 2 key projects, maybe similar to the one that you got from JSXGraph to get funded and produce this wonderful library. And one of the, let's say, deliverables that we have is precisely to build up or to produce a new version of Audiofunctions. And we decided to call it Audiofunctions Plus. So we had the first kickoff meeting in Granada, and while we were there, somehow they were discussing about how to which libraries to use to develop the new application, and I told them that I was using JSXGraph on my student notes and on Moodle or whatever, and they said that it was a good idea. We started producing some, let's say, naive examples, and they like it, so here we are. So that's the reason we're here, because we started using it a lot, and we decided it was a good idea to share it with you in this conference. So the partners of this project are the University of Torino. Mattia is from there. The University of Valle d'Aosta, the University of Granada. I'm from Granada. The KIT, Lukas is from there. The GIS community in Timisoara and Masaryk University. And well, the application is just this. If you open this link, I put the link on the forum so that you can access it. So we have to say that now the application is in the testing phase. We are not only testing the application, but also testing the methodology, let's say the methodological protocol. We want to bring this app to schools and high schools so that we can check if we can use it to teach math functions to visually impaired students. This is the main idea of the application. So the thing is that when you open the application, you see something like this because it has some functions by default. You can turn on the sound by clicking on the icon or by just pressing P. There are several shortcuts that you can use to interact with the application. You can move with the mouse or you can move with the keys, either stepwise or smoothly. So we decided to disable most of the events from JSXGraph and take care of them by ourselves. So by moving to the mouse, you will move smoothly, and by doing this, you will do a stepwise or a continuous by shift and arrows, continuous movement. You can edit functions by pressing F, and you have two kinds of functions. You have functions which are regular functions like this one. You can change it. So for instance, you can say x square. So some of our colleagues from the Czech Republic had problems with this symbol. So we decided to have both, even or the hat or double asterisk. You can also multiply by 10 or do any kind of algebraic operations, right? And of course, you can put asterisk or just leave a space or just a person. So all this is handled by the Math.js library. And then we also have piecewise functions. Let's go to the second function, like this one. Okay, you can switch quickly between functions by pressing 1 and 2. This was important for us because we want students to compare properties of different kinds of functions by listening to them and by switching quickly from one to the other. and then you can edit the function by adding a new parts or in this menu. The thing is that here is like a regular function, but it has a condition, and we store this in an array of a string definition condition, then another array definition condition, and so on. So anytime you try to input something here, so for instance, I can say that x is smaller than 1, it will say no, the two conditions are not independent, and an error will raise, and everything is passed to the screen reader so that the user will hear that something is going wrong. So for instance, if I put this here, then I will get something like that. Notice also that when we have something like this, we don't only draw the function, but we also draw the endpoints. You see, and also you draw, if you, instead of putting a condition like this, you say, so for instance, x is different from 0, and you delete this one, then you will get another point, which is a hollow point, but it's a sticky point. So this point is a point of interest, it is a sticky. So the user also can add in points of interest by hand in a JSON. Lukas will talk about this later. And this becomes sticky, less a sort of magnet. And if you browse through them by using discrete navigation, you will hear an ear cone saying that you pass some point of interest. And that's almost everything I wanted to say. So Mattia, please, I give the floor to you now. Thank you very much for joining us. I will stop sharing my screen.
Thank you, Pedro, for your interaction, and thank you everyone for this library. I'm Mattia, and I knew JSXGraph from Pedro in Granada, as he said just before. And I would like to let you know what Pedro said about the JSX graph. In particular, about the sonification. But first of all, let's understand how we can, what is sonification and why we employed it. Because JSXGraph is mainly a visual tool, but it allows a lot of events from it. You can interact in many ways with it. And since this project, the Sonograph project, is a project for visually impaired people, to let visually impaired people to study mathematical function, we thought we started from the principle to give the same information for sighted people and visually impaired people. And then we try to get the events from JSXGraph and to bring into sound. That is the motivation behind our choice to employ sonification in our software. In particular, which we use a sonification that exploits the exact position of the cursor, that is by mouse or keyboard, as Pedro explained before. And every time the cursor change, the position of the cursor change on the y-axis, the function is evaluated on the y-axis, and then this red dot is plotted on the function. This red dot is mainly what is sonified. So what is the point xy converted into sound? We studied some literature, and we mapped some visual features to auditory ones. And the main feature we exploited is the pitch. Then I activate the sound by playing the P keyboard on the keyboard. Can you hear the sound, right? Okay, that's basically the pitch. The pitch is divided in two main branches. The first branch is what is called continuous sonification. That is almost like this one. Or with stepwise exploration, this is the sound of a clarinet. This sound is like a continuous sound. The pitch, the note is always changing. But there is another modality of playing the function that exploit a guitar. There is not a continuous sound, not a stationary timbre during the time, but it's continuously changing. And then every interval, we divided the y-axis of the JSX graph in intervals equals intervals and play some notes. Then you get a different kind of experience of the same function. Less smooth and more discrete, and can give you an idea of for example, the derivative of the function. And what's the point of all this, how this can happen? This can happen due to mainly two pieces of code. The main piece of code is in the file called graph sonification. In graph sonification, in particular in line 467, there is an important part that can use an effect, and then every time the cursor coordinates change, you reevaluate all the audio pipeline, because all the audio is an entire pipeline. We have different sound with different ear cons that are reproduced when the function has no value for a certain point, when the function exploration crosses the y-axis, or every time the function pitch, the sound pitch change. All is evaluated at each point, and every point is evaluated because every time cursor coordinates change, you reevaluate the entire pipeline and then change and tune some parameters. The other part of this parameter is in what is called keyboard handler, where there is the whole keyboard interaction. You have an arrow left, arrow right, or for particular screen readers, assistive technologies for people, blind and visually impaired people. You can also use some letters, like a move with video games, and then you can set play function and then update cursor. So the keyboard drive the changing visually, and the visual change drive the sonification. This is the loop that allows to have something like that. There is a very subtle sound that means no function is displayed there. Not that the function is not there, but it's not displayed. Because if I cannot see the function, maybe can be a piecewise function. Maybe I only have to zoom out. And then every time the zoom change, all the sonification intervals reevaluates every time. All the instruments are stored in an array of instruments. So we synthesize all the instruments using the ToneGS library and that leverage the web audio API. And then we use that to also add sound to the bass noise, to the bass sound. In particular, for example, if we go to the of the low value, so below 0, you hear not a sound at the time, but you hear a noise. The noise means the function is below 0. The function then stops. And then when you cross the y-axis, you will hear, in addition to the normal sound, also an ear con, like a blip, like a notification, to tell you, oh, you crossed the y-axis. And then you only from auditory senses, and then the last part is a pitch. You can hear the function where you are on the left, from the left ear, and from the right, only on the right ear. So the position of the X is specialized using an algorithm for spatialization, but mainly we tested in our test, and that's it. That's what is about sonification. And then when you get to the boundary, okay, you cannot hear. Okay, we arrive at the end. That's it. That's for the sonification part. Let's please, Lukas, go to the UI part and the project of the whole user interface. Thank you very much.
Yeah, thank you, Mattia. If I am allowed to, I would share also my screen.
Yes, I stopped the share.
So here we are. Yes, my name is Lukas, and I'm from Germany and also working at the sonification project. And I want to talk about the UI elements because, well, basically our overall application is focused on mostly screen reader users, or especially every visual impaired user. But yeah, many of them use a screen reader, so we optimize the whole application for good screen reader experience. So the whole application is focused on keyboard interactions. For example, some of them we already saw, so we can move around the cursor, but we can also move the view of what is currently visible or hearable in our application with WASD. Also, the zooming with the letter Z or Shift Z is possible. And also, if we want to, we can also only zoom a specific axis, for example, the X-axis, all with keyboard shortcuts. In the whole application, you can see there are not many UI elements. Basically, there is two buttons in the header, so a mute and unmute button, the actions button I will come to in a minute, and the main part, our graph, powered by JSXGraph. And maybe what is important for if you implement something like that, our JSXGraph component is completely wrapped into an div element that has the role application. That is important for screen reader users because normally screen readers have a lot of own hotkeys that do a lot of stuff. You don't need to know if you don't use a screen reader, but there can be a problem if you implement a application like that. So what you do is, we just said that it's an application and the screen reader accepts that and then sends us the keyboard events so we can use them in our application. Next to the navigation in the graph, we have a lot of other functionality that is hidden behind a specific menu, and that is behind this actions button or the shortcut Command K or Control K, depending on your operating system. And that's basically command delete tag. It's implemented in many applications for mostly heavy users, but we decided to use it as a main feature here. The idea of that is we have a lot of functionality and we don't want a big list of stuff that can be done because it's not nice to navigate such UIs with a keyboard. So we came up with the command delete that is powered by the K-bar library, and that contains basically everything we can do. For example, we have some quick options like start the audio or maybe show the current coordinates of the cursor. So if I move the cursor, I can also hit the shortcut C. We were able to see it in command delete and you will see the coordinates. And obviously, if a screen reader would be turned on right now, it will be read out. The nice thing about that is that you don't need to know everything that is possible. You can search for it. If I search for coordinates, I will find what I can do with them. I will not go through every functionality that is possible right now, but we can also switch functions like Pedro showed earlier. Also with hotkeys, you can already see them all the time here, and also screen reader will give you access to the hotkeys. So our users can learn it while using the application. Edit functions is also already known because Pedro showed it. So for more complex operations like edit the functions, we can add, by the way, even more functions if we want or delete them. That is no problem. For these complex operations, we have extra dialogues that will open on time and only contains that much of complexity and functionality that is needed. A special functionality that is interesting for our use case is the sharing option and also saving option, because for an educational context, teachers maybe want to prepare a set of functions to give it to the students. And that's specifically a set of functions because already Pedro mentioned it. We want our students to be able to switch between functions, compare them, maybe find intersections or something like that. So it is possible to share a specific set of functions and also a specific state of the complete graph. For example, you see the graph right now. Every time you go to the web page, it opens with the sinus curve as a standard. But what we can do right now, we already edited it. So function 2 is right now in focus. And also we moved the view. What I can do right now is share this whole thing. Maybe activate a restriction mode to read only, so our students cannot change the functions we defined, and share it via link with our students. So to just open that link right now, and you will see the exact same, like it should be. So the complete state of the graph is saved, and yeah, just base 64 encoded in our link, basically. And now you can also see that it's no longer possible to edit the functions, but only to see them. So a student cannot mess up the tasks. Also, if you're a more expert user, you are able to export, sorry, to, I'm in read-only mode, I cannot export. We export the whole thing as a file. If I do that, it downloads a JSON file that looks like that. Pedro already mentioned it. We also save some important points, and yeah, more heavy users could also adjust them right in this file and share that with their students. Right. So maybe I just have a look on the time. Okay. Maybe one more thing I want to mention is the theming, because we have our users are mostly visually impaired users. So the theme is an important thing. So what we did is we're offering several themes. What you can see is now our normal light theme with the colors of our project. We also have it as a dark theme that is interesting for many visual impairments, especially. But if that is not enough, we also offer, for example, a high contrast theme that can be interesting. You can also zoom, by the way, for if you have some problems with seeing. And what is also a big thing, because our project color is green, maybe people, they have problems with differing green and red. We also implemented a special theme, so there is no problem for them. All of this in JSXGraph is handled mostly with the CSS class parameter because, well, we use Tailwind CSS for the styling of our web page and use the new theme feature, and we wanted to keep all in one. So every styling should be handled in the CSS file and is defined there. And yeah, basically that's the most important part. Also, maybe interesting, we used headless UI. We are working with React and use headless UI for the dialogues, for example, because they are pretty good accessible out of the box. The same for the K-bar, so the command delete. But all of that has to be adjusted in a bit. But yeah, that's too much detail, I guess. Yeah, that's it mostly. Thank you for your attention.